Yeah. Good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening, Haripranav, Laksha, Niveda, Prenu, Saparna, Sadhana, Swati, and Bhavishya. Good evening. All right. So, the chapter which we did in the last class or until the last class was linear equations and two variables. Most part of the chapter has been deleted. We have done little more than what you actually need as per the deleted syllabus. Okay. So I don't want to burden you. I shared two materials the other day. You remember one class where I just shared the material and I asked you to work, So we discussed the answers to one material. The other one, I'm just ignoring it because nobody has learned it at all in school, but it is very important. But anyways, I'm just not going to burden you with that. So we'll just leave that material too. We'll not discuss. Next is introduction to Euclid's geometry, then lines and angles, triangles, and all that. But volumes and surface areas is a very important chapter, which is the last chapter, the last but one chapter in the textbook. That should actually be the first chapter. That's the last but one chapter in the textbook. Every chapter is important. Now, this one is very vast. There are many situations, so you need a lot of time to practice. And when we do it at the end of the year, what happens is we don't have time to practice. We don't have time to repeat, which is why I'm going to give you the introduction to the chapter volumes and surface areas today. I'll do that and I'll tell you. Then we'll parallelly do, lines because that's a very vast chapter. That'll go on. There's no end. You can keep working, keep working. So I'll just give you the introduction to the chapter and then, yeah, and then we'll continue with this, like introduction to Euclid's geometry and then lines and angles and so on. See, now we are in the fourth chapter. So we have to do the fifth one. But we're going to the chapter behind the textbook, the last but one chapter, which is volumes and surface areas. We'll take the introduction to that chapter. We'll work a few sums and come back to chapter 5. And then we'll do it parallelly, I said. We'll do chapter 5 and volumes and surface areas, chapter 6 and volumes and surface areas parallelly till we finish volumes and surface areas. All right? All right. So in this chapter, the first solid we see is a cube. So we'll see the formula to find the volume of a cube. The area, now how many faces does a cube have? 6 faces. A cube has 6 faces. One top face, bottom face, right face, left face, front face, back face. Correct? A cube has 6 faces. Top face, bottom face, right face, left face, then front face and back face. So you can just use an object and you can just use an object and understand that. So top face, bottom face, right, left will vary. See, for you, what is right is left for me. So don't mind that. So there is one right face and face is FACE. I'm saying FACE face, not PHAC. FACE face. I'm saying top face, bottom face, right face or whatever. Okay, left face, front face, back face. So like this, both the cube and the cuboid have 6 faces. Both a cube and a cuboid have 6 faces. Correct? So we'll see how to find the volume of a cube and a cuboid. The curved surface area of a cube and a cuboid. Curved surface area is only the area of the 4 faces, not including the top and bottom. When we say curved surface area or lateral surface area, curved surface area is also called lateral surface area. So when we say curved surface area or lateral surface area, it is the area of the 4 faces, not including the top and bottom. Only this one, this one. This one is the curved surface area. So what do you have here? Front face, right face, back face, and left face. Only these make the curved surface area. Which one? Front face, the right face, then back face, and the left face. That is not including the top and bottom. Not including the top and bottom. Curved surface area or lateral surface area is the area of the four faces, not including the top and the bottom face. The remaining faces, front, back, right, left. This is the curved surface area for both a cube and cuboid. Okay, so curved surface area, total surface area. Total surface area is the area of all the six faces. Total surface area is the area of all the six faces. Curved surface area is the area of the four faces, four vertical faces. Because the top face and bottom face are horizontal, right? The top face and bottom face, they're horizontal. The four faces, the other four faces are vertical, they're standing. The front face stands, the back face stands, the right and the left, they're all standing. So they're all vertical faces, which makes the curved surface area. The horizontal faces are the top face and the bottom face. They are horizontal. They're like sleeping like this. The other faces are standing, no? Right, left, front and back, they're standing. So vertical faces. So you can see this room, or online students, whichever room you are in, just believe that to be a cubical room. Just believe the room you are in to be a cubical or a cuboidal room. So you see the ceiling, it's horizontal. See the floor, it's horizontal. But see the four walls, they're standing, no? The four walls are standing, they're vertical. The four walls are the four walls are the four faces that makes the curved surface area or the lateral surface area. Okay, 1, 2, 3, 4 walls. The four walls, the area of the four walls is the curved surface area or the lateral surface area of the cube or a cuboid, depending if it's a cubical room, curved surface area of a cube. If the cuboidal room, curved surface area of a cuboid. See the top face and the bottom face. The top face is the ceiling. The bottom face is the floor, which are horizontal. Okay. All right. So we'll see the formula. So volume is always expressed as area into height. Volume is always expressed as area into height. I'll just show something before this. Now, supposing, there is, you all know the sump, which is a tank in the basement, right? The sump and the overhead tank. You know what a sump is? No? Okay, a tank. Fine, a tank. All right, we'll say a tank. Now, supposing the floor area of the tank, see, I cannot draw the tank precisely. This is a tank. This is a tank. All right. Now, supposing the floor area of the tank, okay, is, let me give you the dimensions of the floor. Close the door properly. I'll give you the dimensions of the floor. Tank, can you imagine? Tank, floor of the tank. The length of the floor is say 10 meters. The breadth of the floor is say 8 meters. What is the floor area then? What is the floor area? 80 meters square. The floor area is 80 meters square. The floor area is 80 meters square. Correct? Now, supposing water stands, so the area of the floor is 80 meters square. Now, supposing water stands in this tank, the water stands to a height of say 2 meters. In this tank, the water is standing to a height of 2 meters. The water is standing to a height of 2 meters. Then the volume of the water in the tank will be the floor area 80 meters square into the height 2 meters, which is 160 meter cube. Is the volume of the water in the tank. The volume of the water in the tank. Okay, the volume of the water in the tank will be the area of the floor. The area of the floor into the height of the water. All right. So area of the floor is 10 to 8, 80 meters square. Into the height of the water, 2 meters. So 80 into 2, 160 meter cubed. You know, volume is expressed in meter cubic units. So 160 meter cubed is the volume of the water in the tank. Now, supposing the height of the tank is given to you. The height of the tank is given to you. Say it is 5 meters. The height of the tank is 5 meters. Then the volume of the tank, not the volume of the water, the volume of the tank is 80 into 5. 80 into 5, 400 meter cubed. So 400 meter cubed is the volume of the tank. But what is the volume of the water in the tank? It's 160 meter cubed, which means to the floor area, if you multiply the height of the water, you will get the volume of the water in the tank. To the same floor area, if you multiply the height of the tank, you will get the volume of the tank. So what volume you get depends on what height you are multiplying. Depends on what height you're multiplying. The floor area is the base. Floor area will not change because the liquid takes the shape of the container. The liquid will not be angry with one part of the floor and say, no, I will not go there. I'll stand only this side. No, when water is filled in the tank, it'll cover up the entire floor area and then it'll increase in height, right? Yeah, so water takes the shape of the tank. So to the floor area, which is computed using L into B, to the floor area, if you multiply the floor area is area. To the area, if you multiply the height of the water, you get the area into height, okay? Area into height. You get the volume of the water in the tank. To the same floor area, if you multiply the height of the tank, you will get the volume of the tank, which is not the volume of the water. So when is the volume of the water equal to the volume of the tank? When the tank is completely filled with water. When the tank is completely filled with water, the volume of the tank and the volume of the water in the tank, both are the same. So how do we find volume? Volume is area of the base. Whatever is the base. Here it's a rectangular base, a tank, no? Tank. It's a rectangular base. The floor is a rectangle. So we said L into B. So we'll see when the shape of the floor is different. When it's a circle or if it is a different floor. The floor, when it is a square, when it's a rectangle, when it's a circle, it will be the area of that floor, whatever is the shape, area of the floor into height. So remember, area into height will give you volume. Area into height is volume. So area, what formula to use? If the floor is a square, then you should say side into side. If the floor is a rectangle, then L into B. If the floor is a circle, then pi r square is all you will have. Is all you will have. So if you multiply the area of the, supposing the floor is circular, then what's the area of the floor? Pi r square. And height, say h. So pi r square into height. Now, what is that solid which has a circular, base and a circular top? What is a solid? Cylinder. Cylinder, which has a circular base and a circular top, is a cylinder. So this pi r square into h is a formula to find the volume of a cylinder. Volume of a cylinder. Cylinder. Circular top, circular base. The top and bottom, they're circular, right? And this is cylinder. And how do you find the volume of the cylinder? Area into height. And what's the area of the base? The base is a circle. The base is a circle. And the area of the circle is pi r square into area into height, h. So pi r square is the floor area into h. Pi r square h is the formula to find the volume of a cylinder. Why? Because volume is area into height. Volume is always area into height. And when we say area, it is the area of the uniform cross section. I'll tell you that, what it means. So In simple words, volume is area into height. So whatever is the floor area into the height will give you the volume of that solid. Because whenever there is height, it's a cube, it's a solid. A plane figure does not have height. A plane figure has only two dimensions. A plane figure has only two dimensions, right? Length and breadth. Only solids have three dimensions. Okay. Yeah, just make a note of all these children. I'll just give them some work. I'll come back to you. Please write down this. I'll explain this. Online students, please give the name of the chapter, volumes and surface areas. In fact, all of you, volumes and surface areas. And write down this. I'll just come back. All right. So cube. The cross section of a cube is a square. So what do we understand by that? Now, supposing you have many squares of side 5 centimeters. Okay, you have paper cuttings. You have paper cuttings of identical squares of side 5 centimeters or say of side 10 centimeters. So what do you have? You have identical paper cuttings of squares, each of side 10 centimeters. Now what you do, you stack, you have many. Now what you're doing is you're going to place the squares, the paper cuttings, one over the other so that they coincide. Not haphazardly, not somehow. You're going to stack it up neatly. Okay, you're going to stack up the squares neatly. You're going to place one square over the above, over the earlier one. Keep placing, keep stacking till the solid you get attains a height of 10 centimeters. Because the length is 10, the breadth is 10. So you keep stacking till you get a height of 10 centimeters. So then what happens? Length is 10, breadth is 10, height is also 10. So that means it's a cube. Because in a cube, the length is equal to the breadth is equal to the height. Correct? So what did you stack to get a cube? Squares, right? Identical squares. So we say the cross section of a cube is a square. When you stack identical squares of whatever side, not 10 centimeters, any side, if the side of the square is 2 centimeters, you should stack it to a height of 2 centimeters. The height should be equal to the length and breadth. Only then it will be a cube. If you take a different height, it will become a cuboid. If you take a different height, it's not wrong. The solid is not a cube, it will be a cuboid. So if you stack identical squares of side, say 10 centimeters, if you stack them, place them one over the other till you reach a height of 10 centimeters, then that solid obtained is a cube. Why? Because the length is 10 centimeters, the breadth is 10 centimeters, and the height is also 10 centimeters. So the solid obtained is a cube, and we say that the cross section of a cube is a square. Right? Okay. So that is a uniform cross section. Because when you stack identical squares to a specific height, you get a cube, right? So a cube has a uniform cross section, which is a square. A cube has a uniform cross section, which is a square. Now, then, what is that solid which does not have a uniform cross section? Say a cone. Cone. Do you think you can stack identical things to get a cone? No. It's like you take a big circle and you keep placing smaller circles above it, and then you get a cone, right? Which means a cone does not have a uniform cross section. It has a cross section, but not a uniform cross section. Every solid will have a cross section, but uniform cross section, not all solids have. Like, for example, a cone or a sphere, a hemisphere. Now, under the meaning, keeping in mind the solids we will be studying, that is cube, cuboid, cylinder, right circular cylinder, right circular cone, sphere, hemisphere. That also I believe is deleted. Sphere and hemisphere, I think it's deleted. Is there? Okay. Yes. So that we'll do, whether it's deleted or not deleted, we are doing it here. So these are the solids we'll be seeing in this chapter, Wellington surface areas. Cube, cuboid, cylinder, right circular cone, sphere and hemisphere. So of these, a cone, okay, let me start with a cube. A cube has a uniform cross section. A cuboid has a uniform cross section. A cylinder has a uniform cross section. A cone does not. A cone has a cross section, but not a uniform cross section. Hemisphere, not a uniform cross section. Sphere, not a uniform cross section. Understand? Because a cone is like this, so you cannot place many identical things one over the other and get a cone. Correct? Similarly, a sphere. A sphere. You cannot place many identical things and get a sphere or a hemisphere, which is half of this, or a hemisphere, which is half of this. But when it's a cylinder, when it's a right circular cylinder, see a right circular cylinder like this. So if you have many identical circles of radius 5 centimeters, you have identical circles, say radius is 5 centimeters. You just stack them, you place them one over the other, you will get a cylinder to any height. To any height. When you stack identical circles to any height, the solid obtained is a cylinder, which means the cylinder has a uniform cross section, which is a circle. Similarly, a rectangle, sorry, a cuboid has a uniform cross section, which is a rectangle. When you place identical rectangles one over the other, you will get a cuboid. When you place identical rectangles, not big, small rectangles, identical rectangles. When you stack identical rectangles to any height, you get a cuboid. You get a cuboid, right? So when you stack identical squares to a specific height, you get a cube. Identical rectangles to any height, cuboid. Identical circles to any height, cylinder, right circular cylinder. So these three solids have a uniform cross section, square, rectangle, circle. While the others, cone, hemisphere, and sphere, do not have a uniform cross section. And volume is defined as area of the uniform cross section into height. Volume is area of the uniform cross section into height. So we can apply that formula for cube, cuboid, and cylinder. What formula? Area of uniform cross section into height. That can be applied to cube, cuboid, and cylinder. These we'll see how later. These we'll see. Okay. So volume is area of the cross section into height. What's a cross section? It's a square. What's a cross section? It's a square, right? So what's the area of the square? A square. Into height is A. To a height of A units. So A cubed is the formula to find the volume of a cube. Curved surface area. Curved surface area is expressed as perimeter into height. Curved surface area is expressed as perimeter into height. Perimeter of the uniform cross section into height. Volume is area into height. CSA, that is a curved surface area, is perimeter into height. Now, what is the perimeter of the cross section? What does the cross section square? What is the perimeter of the cross section? 4A. Perimeter of the cross section is 4A. Why 4A? Because perimeter of a square is 4 into A. Okay, into height. What's the height of the cube? A units, right? A. The height of the cube is A. The perimeter of the cross section, which is a square, is 4A, and the height of the cube is A. So 4A square is a formula to find the CSA of a cube, which is nothing but the area of 4 walls of a cubical room. For a cubical room, it is the area of 4 walls. Total surface area is the curved surface area plus the area of the base plus the area of the top. What's the CSA? 4A square. Area of the base is a square, so A square. Area of the top is also a square in the case of a cube. So A square, so 6A square units. Supposing we are talking about an open cubical tank. If we are talking about an open cubical tank, okay. Now you have jumped inside. The tank is empty. The tank is empty. And where are you? You're inside the tank. Okay. And say it is the tank in your house and you want to paint it up. Where all will you paint? You'll paint the floor. And you'll stand out it only. Anyways, you'll paint the floor. Then you'll paint the 4 walls. the cubical tank is open. So there is no roof to paint. It's open, right? So where all will you paint? You will paint the floor, then you will paint the 4 walls. That's all. No more surfaces are there. You're painting the inside of the tank. You're painting the inside of the tank. Only the inside you're painting. Where are you painting? Only the inside you're painting. You have jumped into the tank. You're painting only the inside. Whatever you see inside the tank, you're painting. What will you see inside the tank? The 4 wall surfaces you will see. The surfaces of the 4 walls and the floor. And it's what tank? It's a cubical tank. So what is the area of each wall? A square. What is the area of each wall? Each wall is a square, right? The surface of every wall is a square. The surface of every wall is a square. So what will be the area? A square, A square, A square, A square. And what is the shape of the floor? Square. So what's the area? A square. So what's the total area you will be painting? 5A square. 5A square. So if you're painting the 4 walls, 4A square. If you're painting the 4 walls and the floor, 5A square. If you're painting the 4 walls, the floor and the ceiling, 6A square. There is no 7A square. There is no 7A square. So it is 4A square, 5A square, 6A square. 4A square if you're painting the 4 walls. 5A square is 4 walls and the floor. If it is 4 walls, floor and the ceiling, 6A square. Why? Because every surface is a square and the area of a square is A square. So remember, if you have to paint only 5 faces, it is 5A square. All right. Length of the diagonal. The length of the diagonal. Now, what is a diagonal? What's a diagonal of a cube? It is the line segment that connects any bottom corner to its opposite top corner. You take any corner of the cubical room. Take any corner of the cubical room. The line segment connecting a bottom corner. Take any bottom corner, okay? Because corners are on the top and the bottom. Corners are in, like on the floor and on the ceiling, right? Take any bottom corner and connect that to the diagonally opposite top corner. The diagonally opposite top corner. Step 1, choose any bottom corner on the floor, any corner on the floor. Connect that to its diagonally opposite top corner. So like from that corner to that corner. To that corner will be the diagonal. Will be the diagonal of the cube. And the diagonal of the cube is given by the formula √3a units. Because Pythagoras theorem, it's very simple. It's Pythagoras theorem because see you can see here, children. You can see here. This is one bottom corner, and this is the opposite top corner, and this is the diagonal of the cube. Now, see, this one is a right triangle. 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 So the diagonal of the cube is the hypotenuse of the right triangle. The diagonal of the cube is the hypotenuse of the right triangle we see here. Now, this side of the right triangle is A units. And this side of the right triangle is nothing but the diagonal of the square. The floor is a square, right? The floor is a square, and that line segment is the diagonal of the square, and diagonal of the square formula is √2a. If you've forgotten, recall that. √2a is the formula to find the length of the diagonal of a square. If you've again forgotten, if you feel no, how is it possible? How is it? Then this is how it is. A. So by Pythagoras theorem, find this one. Find this by Pythagoras theorem. How will you find it? You call it ABC. AC square is equal to AB square plus BC square. So AB square is A square plus A square. So 2A square. AC square is equal to 2A square. So AC is equal to square root of 2A square. AC is equal to root 2. A comes out of the square. Root 2A units. It's cold? I'll turn it off. Is it cold? Shall I turn it off? No. Yeah. Diagonal of a square, children. Diagonal of a square. Square. Diagonal. A, B, C, A square. Let us find AC. AC square is equal to AB square plus BC square is Pythagoras theorem. So A square plus A square, 2A square. AC square is equal to 2A square. So AC is equal to square root of 2A square, which is root 2A units. So the length of the diagonal of a square is given by the formula root 2A. So this one is root 2A. This is root 2A because this is the diagonal of the floor, which is a square. The diagonal of the floor, which is a square, and that's root 2A. And this one is A. So this is the hypotenuse of the right triangle. Pythagoras theorem. Okay, Pythagoras theorem. So if I call this A, B, okay, let me say PQR. If we say P, Q, and R, this is the right angle. This is the right triangle. Okay, this is the right triangle. So what is it? PQ square, the hypotenuse square. The square on the hypotenuse is equal to the sum of the squares of the other two sides. So is equal to PR square plus QR square. Correct? So PR square is root 2A, the whole square, plus QR square, A square. So is equal to root 2 square is 2. A square plus A square, which is 3A square, 3A square. So PQ square is equal to 3A square. So PQ is equal to square root of 3A square. So PQ is equal to root 3A units. A square comes out of the square root as A. So root 3A units. All right. So the length of the diagonal of a square is root 2A units. The length of the diagonal of a cube is root 3A units. All right. Square is root 2A. Cube is root 3A. So that's the length of the formula to find the length of the diagonal, root 3A units. Now the length of all the edges. So how many edges does a cube have? Let's count. Okay. Let's count the edges of a cube. So on the top, it has 1, 2, 3, 4 edges on the top. Bottom, 1, 2, 3, 4 edges bottom. Okay, then the standing edges. 1, 2, 3, 4. All right. I'll show you again. See here. Lengthwise, it has 1. See, this is lengthwise. 1, 2, okay, 3 and 4 lengthwise. Along the length, it has 4 edges. Along the breadth, 1, 2, 3, 4. 4 edges along the breadth and 4 more edges along the height. 1, 2, 3, 4. 4 edges along the height. But all these are equal to A units, right? So 4 edges along the length, 4 edges along the breadth, 4 edges along the height. 4 plus 4 plus 4, 12. You can add because each edge is equal to A units in a cube. It's a cube. Every edge, length is A, breadth is A, height is A, all A only. So 12A. A plus A plus A plus length of the edges, no? A plus A plus A plus A plus A, 12 times. We counted how many edges? 12 edges, right? And what's the length of each edge? A units. So 12 edges will be 12 into A, 12A units. So now supposing you have to, you have, wrapped a gift in a cubicle box. You got a gift for your friend and you have put that gift inside a cubicle box. You put that gift inside a cubicle box. Now just say you want to decorate the edges of the gift box with lace. With lace. It's a decorative, like ribbon kind of. Yeah. Yeah, it's a kind of ribbon. All right. Okay, so you want to stick lace. You want to decorate it. So you want to stick lace along the edges of the cubicle box. So what is the length of the lace you would need? So if the edge of the cubicle box is 5 meters, if the edge of the cubicle box is 5 meters, then you will need 12 into 5, 60 meters of lace. 60 meters of lace. If you want to decorate the cubicle gift box with lace by sticking lace along all its edges, only the edges, not all over, only along the edges. Then how many edges? 12 edges. What is the length of each edge? 5 meters, for example, 5 meters. So what will be the length of the lace you have to buy from the market? 60 meters. So maybe you will buy 10 meters extra because some wastage and all. Maybe, I'm saying. But exactly you need 60 meters. So that's when you will use this formula. You'll be wondering why should you know all this length of all the edges. So if you have a question like this, what will be the length of the lace required? Then you should use 12A. Then you should use 12A. So length of all the edges 12A, length of the diagonal root 3A, total surface area 6A square. There is a formula 5A square also, you know when to use it. 4A square is only the 4 walls. Then A cube is volume. All right. You should have taken the diagram also. Online students, any questions?
No, ma'am.
All right, children. Yeah, very nice, children. Yeah. Children, please, have you taken down the diagrams also alongside? No.
Yes, ma'am.
Yeah, good. So that looks like Anirudh. Yeah, Anirudh, then you were not there when I started the meeting. Were you late?
Ma'am, I was in the meeting, ma'am, when you started.
Oh, okay. Fine. All right, children, if you have not taken the diagrams, please take down the diagrams. Is it cool? Done, children? Yeah. So let me tell you, the others you will understand. Let me just tell you about the length of the diagonal of a rectangle. Okay. Listen to this. Don't write down anything. Rectangle, length, breadth, diagonal. This is also L. Oh, sorry, this is B. This is L. Now say it is M, N, O, P. Okay. So let us find the length of the diagonal OM of this rectangle MNOP. Okay, so by Pythagoras theorem, the square on the hypotenuse OM square is equal to the sum of the squares of the other two sides, MN square plus ON square. Correct? In the right triangle, in which triangle? MNO. In triangle MNO, OM square is equal to MN square plus ON square. So OM square is equal to what is MN? B square plus ON L square. So OM is equal to square root of L square plus B square. L square plus B square. So square root of L square plus B square is the formula to find the length of the diagonal of a rectangle. Rectangle, diagonal, length formula is square root of L square plus B square. Now, square root of L square plus B square is not L plus B. It's not L plus B. You cannot take out individual square roots like that. Square root of L square plus B square is square root of L square plus B square only. So you should substitute what the values and then calculate. It's not L plus B. Square root of L square plus B square is not L plus B. So what's the formula to find the length of the diagonal of a rectangle? Square root of L square plus B square. Now we'll use that here to find the diagonal of a cuboid. You can see here, diagonal of a cuboid. The line segment that connects any bottom corner to its opposite top corner is the diagonal of a cuboid. And to find the length of the diagonal of the cuboid, we take this right triangle. All right. So this one is H. And this one is the diagonal of the rectangle, the floor, rectangle. Floor is a rectangle. And this one is the diagonal of the rectangle, which is square root of L square plus B square. And when you use Pythagoras theorem, I'll work it later for you. Later meaning you write down this and then I'll work it for you. When you use Pythagoras theorem, you will find that the length of the diagonal of the cuboid is root of L square plus B square plus H square. It's easy to remember. For a square, it is root 2a. For a cube, root 3a. For a rectangle, root of L square plus B square. For a cuboid, root of L square plus B square plus H square. All right. Yeah. Please write down all this. Take down the figure also alongside. You don't have to draw it so big, but please draw. Online children, please write down this. I'll just come back. The entire, like activity in deriving the formula is very similar to that of a cube. So again, cross section of a cuboid is a rectangle. You understand area of the cross section into height. Cross section is a rectangle, and area of the rectangle is L into B into H. What is the area of the cross section? It's a rectangle. And what's the area of a rectangle? L into B into height. So LBH cubic units is the formula to find the volume of a cuboid. Then curved surface area, perimeter of the cross section to height. And what is the cross section? It's a rectangle. And what's the perimeter of a rectangle? 2 into L plus B. So 2 into L plus B is the perimeter of the cross section, which is a rectangle. 2 into L plus B is the perimeter of the rectangle into H, which can also be written as 2H into L plus B. Or you can write it like this itself, 2 into L plus B into H. This is also fine. Or you can write it like this, as you see here, 2H into L plus B square units. Area is always expressed in square units. Now total surface area. Curved surface area is only the area of the four walls. If the cuboid is a cuboidal room, then the area of the four walls is the curved surface area. Correct? Curved surface area is the area of the four walls. Now the total surface area will be the area of the four walls plus the area of the ceiling plus area of the floor. Correct? Total surface area will be area of the four walls plus the area of the ceiling plus area of the floor. So what is the curved surface area? 2H into L plus B. Area of the base, it's a rectangle, L into B. Ceiling is also a rectangle, L into B. Both the floor and the ceiling, they're rectangles. So L into B is the area. So L into B plus L into B. Yes or no? Okay. So now open up this bracket. Open up this bracket. So you'll get 2LH plus 2BH. Open up the bracket. You will get 2LH plus 2BH. 2LH plus 2BH. And LB plus LB is 2LB. LB plus LB is 2LB. And now when you take out 2 common, you will get 2 of LB plus BH plus LH square units. When you take out 2 common, you get 2 of LB plus BH plus LH square units. Correct? This is the formula to find the total surface area of a cuboid. Now, supposing you are now inside a cuboidal water tank. You are inside a cuboidal water tank and you're doing the same activity. You're painting up the four walls and the floor. You're inside an open. You're inside an open cuboidal tank. Open cuboidal tank. And what you have to do is paint up the four walls and the floor. Then what is the area you're painting? So you're painting the four walls, which is 2H into L plus B. And you're painting the floor, which is LB. That's all. This is the expression. This is the expression that you should use to find the area of the four walls and the area of the floor. If in some situation you have to find only the area of the four walls and the area of the floor, then this is the formula. This is also the formula to find the area of the four walls and the area of the ceiling. Suppose in some case, area of the four walls and the ceiling. This one is area of four walls, area of ceiling, area of floor, all put together is TSA. What is TSA? Area of the four walls, area of the ceiling, area of the floor, all put together is total surface area. So if you don't want the total surface area, but you want the area of the four walls and only one, either ceiling or floor, then you should write this one, 2H into L plus B plus floor or ceiling, whichever you want, LB. Both is LB only. Because the ceiling and floor, they are identical, no? The ceiling and floor, they are identical. In a cuboidal room, the floor and the ceiling, they're identical. So that is about this one. And then the length of the diagonal is root of L square plus B square plus H square units. Edges, same 12 edges, children. But the thing is, they have different lengths. The 4 edges along the length, The length is different, the breadth is different, the height is different. There are 4 edges. See, this one is length. This one is L. This edge is L. This edge is L. And this edge is L. So 4L. Then this is B, this is B, this is B, this is B. So 4B. And this is H, this is H, this is H, and this is H. 4H. So here you have to write separately. You cannot write 12 because length, breadth, height, they all have different, values. All right. So the length of all the edges is 4L plus 4B plus 4H units. And how do you use Pythagoras theorem to find the length of the diagonal of a cuboid? Okay. So this one is the diagonal of the rectangle, which is root of L square plus B square. And this one is H. So we have to find this, which is a diagonal, right? So let me just mark it ABC. So AB square is equal to BC square plus AC square. So BC square, root of L square plus B square, BC square plus, correct? BC square. So root of L square plus B square, the whole square. Now the square and square root will get cancelled, right? So we have L square plus B square plus H square. What is this? This is AB square. So what is AB then? AB is equal to square root of L square plus B square plus H square. So it's simply Pythagoras theorem. Square root of L square plus B square plus H square. So this is the triangle. I'll just show you the triangle again. This is the triangle. One side of one leg of the triangle is the diagonal of the floor, which is root of L square plus B square. The other leg of the right triangle is the height of the cuboid, which is H. And this is the diagonal of the cuboid. This one forms a right triangle with this side H and with this side, and with this. Oh my God, why am I not able to write? This one is root of L square plus B square. This one is H, and we have to find the hypotenuse, right? So volume is area into height. What is volume? Area into height. Area is L into B into H. So LBH cubic units. Curved surface area is perimeter into height. Perimeter is 2 into L plus B. Perimeter of a rectangle is 2 into L plus B into H. Is the curved surface area of a cuboid. Total surface area 2H into L plus B plus LB plus LB. Then when you open the bracket and then take out 2 common, you will get, are you listening? Ayagamai? No, you're not listening. You're dreaming. Where did I stop? Only even you cannot hear yourself. Where did I stop? Yeah. Okay, so I was telling when you take out 2 common, okay, when you take out 2 common, you will get 2 of LB plus BH plus LH. Then I said if one face is not included, then it will be 2H into L plus B plus, if you want to include the ceiling, plus LB. If you want to include the floor, plus LB. Curved surface area is 2H into L plus B. Plus, you can add the area of the ceiling or the area of the floor, whichever, according to the question or the situation in the question. Length of the diagonal, root of L square plus B square plus H square, and length of all the edges is 4L plus 4B plus 4H. All right. Finish writing, online students?
Yes, ma'am. Yes, ma'am.
Yeah, very good. Very good. Yeah. Yeah, take down this, children. I'll just come back. Please write down this.
Hmm?
So the cross section of a right circular cylinder is a circle. We know that, right? Okay. Area of uniform cross section into height. Area of circle. So pi r square into h. Pi r square h is the volume, correct? And then CSA, perimeter of the cross section into height. Cross section is a circle. Perimeter meaning circumference. So 2 pi r. 2 pi r into h. 2 pi r h is the formula to find the CSA of a cylinder. So what is CSA? The curved surface area. Oh. Yeah. Yeah, children. So CSA, the curved surface area. Okay, so if I make a cylinder from this paper, okay, this cylinder, this one is a cylinder which is open at both the ends. This is a cylinder which is open at both the ends. And what will be the curved surface area? This one. This one is the curved surface area. This full thing is the curved surface area. The total surface area will be the curved surface area plus the area of the circle on the top plus the area of the circle below. If there were circles. When it's closed, you know, if it's a closed cylinder, there'll be a circle on the top and a circle at the bottom, right? What you see here is a curved surface area. This one is a curved surface area. Am I showing it properly? Curved surface area. This is given by the formula 2 pi RH. 2 pi RH is the formula to find the curved surface area of a cylinder. Total surface area is the curved surface area plus the area of the top and the bottom. What is the top? Pi r square. What's the bottom? Pi r square. Area, pi r square. So 2 pi RH plus pi r square plus pi r square, which is 2 pi RH plus 2 pi r square. On taking out 2 pi r common, you'll get 2 pi r into r plus h square units. So if supposing it's a tumbler, okay, we'll come to that. So is this understood? 2 pi RH is a CSA plus a circle on plus the base circle plus the top circle. Pi r square plus pi r square is 2 pi r square. 2 pi r is common. So 2 pi r into r is 2 pi r square. See here, 2 pi r into r is 2 pi r square. 2 pi r into h is 2 pi r h. You can write it anyways, children. You can write 2 pi r into h plus r also. Both are fine. 2 pi r into h plus r or 2 pi r into r plus h square units. H plus r. So 2 pi r into h. 2 pi r into h is 2 pi r h. 2 pi r into r is 2 pi r square. So now this formula you will use when it's a closed cylinder. That is, there is some area, the curved surface area to be painted, when there is a circle on the top to be painted, and when there is a circle at the bottom also to be painted. If the cylinder is made up of two circles, two flat, you know, the two circles on either ends and the CSA, then you should use this formula. Then you must use this formula. This is the formula to find the total surface area of the cylinder, which is the curved surface area and the area of the top and the area of the base. But in the case of a tumbler, it's open at the top, right? Look at this tumbler, the steel tumbler. It's open at the top. Normally, when we say tumbler, it's open at the top, no? The tumbler can be of any shape, but here, this one, in this figure, it's a cylindrical tumbler. In this one, it's a steel cylindrical tumbler. What you see here is a steel cylindrical tumbler. Normally, when we say tumbler, it's open at the top. Now, when we say water bottle, it's closed. You cannot say that my water bottle is open. Then, okay. Now, don't show me an open water bottle. Okay. Now, so in the same way, when we say tumbler, it is open. When we say tumbler, now don't say I have a tumbler in my house with a lid. Okay, so if the tumbler has a lid, it will be given in the question. If the tumbler has a lid, it will be given in the question. If nothing is mentioned, if only the word tumbler is used, that means it's open at the top. If simply the word tumbler is used, cylindrical tumbler is used, it is open at the top. If it has a lid, suppose, it will be given to you in the question. Because when we say tumbler, it is open at the top. If this is a special tumbler which has a lid, it should be given that the tumbler has a lid. Otherwise, it was open at the top. So in this case, and also one more thing is here, TSA. Now you will think, okay, I've made this mistake of writing TSA. See, for the tumbler, it is a total surface area. For the tumbler, find the total surface area. That is what all the area which is available in the tumbler is the total surface area of the tumbler. You should not be deceived or misled by the word total. What are you doing? Take out your hand. Yeah. You also. You are laughing and smiling to yourself. Were you sitting alone, by the way, today? Simply. Okay. For the tumbler, it's a total surface area. Don't get confused. Like if the word total surface area is used in the question, does not mean that you should use this formula only. For a tumbler, what is the total surface area? It is the CSA plus pi r square. This is only the total surface area for a tumbler. This is the total area available in a tumbler. In a tumbler, what do you have? You have the curved surface area. Yes. And then there is no circle on the top. There is no circle. On the, meaning there is no material used for the circle. There is a circle on the top, but there is no material used. It's open, right? There is no, the steel material is not used on the top, I'm saying. The material steel is not used on the top circle. It's open. The bottom circle, there is steel. It's covered, no? So there is steel in the bottom circle. So when you're finding the total surface area of the tumbler, you're finding the area of the steel used in the tumbler. When you're finding the total surface area of this steel tumbler, you're finding the area of steel in the tumbler, the area of steel in the tumbler. So where all is this material used? It's in the CSA. And there is a top, but it's the steel is not used there. So leave that. In the bottom, the base is covered. So there is steel there, pi r square, which is 2 pi RH plus pi r square. So you should, this formula you should, or this expression you should create according to the situation. Just because they say total surface area of the tumbler, you should not take this formula. This formula is only when both the top and the bottom circles are covered with a material. The material can be wood, the material can be steel, it can be plastic, whatever material. If it is used to cover the top and cover the bottom, then it is this formula. If that material is used on the top and bottom, then it is this formula. Here, in this tumbler, the material steel is not used on the top circle. It's open. It's used only for the bottom circle. So we should create this formula, 2 pi RH, which is the CSA plus pi r square. So when you take out pi, this is not needed, but I've just written it. When you take out pi r common, you'll get 2. When you multiply these two, you'll get 2 pi RH. When you multiply these two, you'll get pi r square. This is not needed. You don't have to remember the formula like this. This is enough. 2 pi RH plus pi r square. All this is important. This you should remember. I'm saying only this. This is not needed. You can just remember this. Okay. Correct. Now this one I'll talk to you about this one when we come to a question. Also, it's not visible here. What I've written here and here is not visible. So just ignore this for now. I don't know. Sorry how you wrote down this. Maybe you've just drawn the figures. You've not written anything because it's not visible, right? Yeah, it's okay. Just leave it. We'll just take up a situation and then I'll explain this. You would have written this, children. I know you would have drawn this, but since this is not clear, you would have left it empty. We'll complete this in the next class. Or if you guessed it and you have filled it, fine, let it be there. All right. Is it okay till here? So you can actually see the formula because you know the cross section is a circle. The cross section is a circle. So what is volume? Area of cross section into height, pi r per h. You can just see it in your mind. Then what's the curved surface area? Perimeter. CSA is perimeter into height. CSA is always perimeter into height. Perimeter means 2 pi r. 2 pi r h. Correct? And then total surface area will be 2 pi r h plus pi r square plus pi r square. So 2 pi r h plus 2 pi r square. Then when you take out 2 pi r common, you will get 2 pi r into r plus h or h plus r. Then in the case of a tumbler where one circle is not there, where material is not used for one circular portion, then it is 2 pi r h plus pi r square. 2 pi r h is a CSA plus pi r square. All right. Yeah. Try this question, children. Please take down this question. Now we are going to work problems based on cube, cuboid, and cylinder. Then once we do a little of this, then I'll tell you about the formula regarding cone, hemisphere, and sphere. All right. Yeah. Online students, please take down this question and try it. What happened? Taken this question? Taken the question, children? Aragami, please copy from your friend. Yeah, try this one. After that, try not this. This one. Finish answering the question you have taken down in your book now. Finish that and then try this. Yeah, what's the answer with the first one? What's the final answer with the first one? Yeah,
7140.
7140. No, there's a slight difference. Yeah, all of you here? Couldn't do that? All right. Okay, Swati, see this? I'm getting 7020, Swati. All right, children. So see here, a room is 16 meters long. A room is 16 meters long, 9 meters wide, and 3 meters high. Clearly, it is a cuboidal room. Why cuboidal room? Because length, breadth, height, all are different. It's a cuboidal room. It has 2 doors. All right. But the length, breadth, and the height of the room will be including the door only. See, when you're measuring the length of the room, you will not leave the door. You will measure end to end, right? The door will be there in the middle. Okay. It has 2 doors. Dimensions are given. The dimensions are the dimensions of the surface of the door. The door on the whole is a cuboid. The door is a cuboid. It's thick, no? The door is not a rectangle. Door is not a rectangle. It's a solid, right? It's cuboidal. But we are not talking about the entire door. We are talking only about the surface of the door, because where will you paint or where will you distemper? Only the surfaces. Okay, so we are talking about, see, like inside, you can only see the rectangular portion of the door, right? Now inside this room, inside that door, you can only see the rectangular portion of the door. So it has two doors. The dimensions are the dimensions of the surface of the door. Okay. And three windows, each of dimensions. Again, windows, the window will be thick. The dimensions are the dimensions of the surface of the window. The length and the breadth of the window. Only the surface. Okay, only the surface. Find the cost of distempering the walls of the room. Find the cost of distempering the walls of the room from inside at the rate of ₹50 per square meter. Find the cost of distempering the walls, only the walls. Find the cost of distempering only the walls from the inside, not the ceiling. The floor is tiled. What do we do with the floor? We don't paint the floor or we don't distemper the floor. The floor is tiled. The floor is tiled, so leave the floor. What other things can be distempered? The four walls and the ceiling. Correct. What can be distempered? The four walls and the ceiling. But the ceiling is not mentioned here. Find the cost of distempering only the walls of the room. Only the walls, not the ceiling. From inside at the rate of ₹50 per meter square. So the formula to find the area of the four walls. The area of the four walls is what is to be distempered. And the formula is 2h into L plus B. But we must remember that this area includes the area of the doors, the two doors and the three windows. Where are the doors and windows? On the walls. It will be on, somewhere on the four walls. The two doors and the three windows will be on the walls, right? So when you find the area of the four walls, it includes the areas of the doors and windows. It includes. But the windows and the doors, you will not distemper. You will paint it. That you use a different material for that. Correct. Distempering is using powder. The powder is mixed with water and, that is distempering. That cannot be put on the doors and windows. Windows and doors cannot be distempered. Okay, they are painted. Windows and doors are painted. Only the cement surfaces can be distempered. What can be distempered? Only the cement, the rough cement and brick surfaces, that can be distempered. The doors and windows, which are made of iron and steel, they can be painted, not distempered. But when you find the area of the four walls, children, when you find the area of the four walls using the formula 2h into L plus B, this is the formula, right, to find the area of the four walls. This one includes the area of the areas of the two doors and the three windows. So what you should do is you should find 2h into L plus B, find the area of one door, multiply by 2. Find the area of one window, multiply by 3. Add the areas of the two doors and the three windows. You get one answer, right? Area of the four walls minus that area. Find the area of one door, multiply by 2. You will get area of two doors. Find the area of one window, multiply by 3. You will get area of three windows. Add the areas of the two doors and three windows. So you'll get the total area, which is not distempered. Now the area of the four walls minus the area of the two doors and three windows. What you get? That is only the actual area to be distempered. From the total area of the four walls, you should take away the areas of the doors and windows. That is the area to be distempered. That into 50 will give you the cost of distempering the walls, because for 1 meter square, 50 rupees. So that area which you get into 50 will give you the cost of distempering the walls. You can see here. Area of four walls, 2h into L plus B. 150. Area of one door, two doors will be 2 into 3, 6. I think I'm fast. 1 second. Area of one door is 3 children. Area of two doors will be 2 into 3, 6. Area of one window is here. 3 windows is here. Then I've numbered it. See here, presentation is very, very important. I've numbered it. This 2 doors, I've called it. See here, I've called this 1. I've called this one 1. Then I've called this area of 2 doors as 2 and 3 windows as 3. Now, the area not to be distempered or area not distempered will be 2 plus 3. 2 plus 3 will not be distempered. That is total is 9.6. Area to be distempered. The area to be distempered will be 1 minus 4. You understand what's happening? 1 minus 4, 140.4. Only this is to be distempered. Now the cost of distempering will be the area to be distempered into the rate. So area into rate, which is the total cost. Swati, you said 7140. I think you found the area of the ceiling also.
No, ma'am, I forgot to multiply 1.2 with 3 so that I can get 3.6.
Oh. No, but you got a larger answer, no?
Yes, ma'am, I multiplied like 3.
Yeah. Right. I get it. Okay. Now coming to handling the units. There is one odd unit here. See here. This one is in centimeter. This is in meter. This is in centimeter. So instead of changing everything to centimeter, change this 1 centimeter to meter. Everything, all the values are in centimeter. All the values are in meters. And also the rate is given 50 rupees per meter square. 50 per meter square. Everybody is in meter. Only this one is odd one out, 75 centimeters. So convert that to meters. So 75 centimeters. How do you convert that to meters? 75 by 100 meters. Divide by 100. To convert centimeter to meter, divide by 100. So 75 by 100. It's converted to meters now. So 25 3s are 25 4s are. So 75 centimeters is nothing but 3 by 4 meters. 3 by 4 meters. So that's what you see here. See here, I've written length, breadth, height. Please see the table, length, breadth, height. I've written for window, door, and room. For the room only, you'll have length, breadth, and height. Length, breadth, and height for the room. For the door, only length and breadth. Length and breadth for the door, length and breadth for the window. And I've converted the breadth, 75 centimeters to meters. Height you will not have. For this and this, no height. Only surface area, no, L into B. Now, see here. So now you can use the values. You will not go wrong. 2H into L plus B is area of 4 walls. Area of 2 doors. Area of 3 windows. Add these two. You have it here. And this one, 150 minus 9.6 will be the area to be distempered. And this one into 50 rupees will be the cost of distempering. All right. I'll share a picture of this one. Just explain this and wind up the session for today. So here, yeah, anybody got the answer for this? Just share what?
216 meter cube, ma'am.
216
meter cube, ma'am.
216 meter cube. Okay, fine. 216 meter cube. Yeah, 216 meter cube. Okay, so what do we have? The length of a cold storage is double its breadth. Length is double. Length is more. Length is double its breadth. So if the breadth is x, the length will be 2x. The length is double its breadth. So if the breadth is x, the length will be 2x. And what's the height? 3 meters. Okay. Now what is given? The area of 4 walls is 108. Area 4. See, the question is to find the volume. To find the volume, To find the volume, you need L, B, and H. You know only H. You don't know L and B. The question is to find the volume. To find the volume, you need the value of L, the value of B, and value of H. The value of H is given in the question. L and B is not given. If L and B is not given, then how can you find the volume? So you should find L and B. Now, to find this L and B, some other information will be given to you in the question. To find this L and B, some other information will be given in the question for you. And what is that extra information? Why have they given area of 4 walls is 108 meters square? Why should they give you? The question is to find volume. And for volume, they should give what? L, B, and H. Okay, they've given H. They've not given you L and B. Why should they give you the area of 4 walls? That's because since they've not given the values of L and B, they've given you this information. Area of 4 walls is 108. Using this, you should find L and B. Some extra information is given. You should use that to find L and B. So your first step is not to find the volume, but to find L and B. Only if you have that, you can find volume. So to find volume, to find L and B, you're given this information. Area of the 4 walls is 108. Area of 4 walls is 108. Write down that first. Why should we write that? Because that information is given to find L and B. That extra information is given to find L and B. So write that. Area of 4 walls is 108. That means 2H into L plus B is 108. 2 into H is 3. Into L plus B, X plus 2X is 108. So when you work this, you'll be able to find the value of X. When you work this, you can find X. And once you find X, the breadth is X. The length is 2 into X. So you can find the length and breadth. On solving this, you'll get X. And using X, you can find the length and breadth. Now you see, you found the length and breadth using this information 108. That's why it was given. Now find the volume, which is L into B into H. All right. Okay, I'll share these images on WhatsApp, children. All right, children. So that's it for today's session. Thank you so much. Online students can leave the call. Good night.
Thank you, ma'am.
Thank you, children. Good night. Thank you, children. Good night. Thank you. Good night.